Hello everyone. Today we're going to be going over ratios and proportions, more specifically how to simplify ratios and or how to solve a proportion. So just before you started this lesson, we made a comparison of the classroom of how many boys there were and how many girls were in the classroom. So we call comparison between two or more quantities a ratio. So that's what we call a comparison of things. So what we found out was the ratio of boys to girls in this classroom. So again, we just found the ratio of boys to girls. Now the question now is the ratio of girls to boys exactly the same? So if I ask for the girls to boys as opposed to boys to girls, is it going to be the same ratio? And the answer here is no. So make sure you write this out. No. When writing a ratio, order matters. So if I say boys to girls, the order of the numbers that we write out matters. So again, make sure we are writing this down on your paper. All right, once you've written it down, let's go ahead and move on. All right, so again, just one more time, a ratio is a comparison between two or more quantities. So I could have compared three different things, like three different the favorite colors from three options in the classroom, and so on. So the order of the comparison matters. Again, boys to girls, girls to boys. It's very, very important that as you read these ratio problems and you are writing out your own ratios, the order in which they ask for the ratio is correct. All right, so there are three ways to actually write ratios. You can see them in any of these three different ways. The first one is just in words, 5 to 7. That would be one way of saying it. So again, just first quantity, the word TO to second quantity. So first number to the second number. Another way of writing a ratio is using the colon sign. So first, dot, dot, second. So you put the two numbers in between that symbol. And the third way we can write a ratio is as a fraction. So 5 over 7, first number divided by the second number. And again, we write it as a fraction. The first one, the top number, the numerator would be the first number in the ratio. Bottom number would be the second one as you say it. All right, so again, always, you want to make sure you are careful because the order matters in a ratio. It's 5 to 7, and again, it's not the same as 7 to 5. So what are some things that we look at and use ratios for? So like TV screens have a ratio, and so do many other things. Again, when it comes to recipes, we use ratios as well. How much milk compared to how much sugar or how much butter we put in a recipe, and so on. All right, so let's look at some ratios that we have in our actual paper. So what is the ratio of basketballs to football? So we would count each one. In this case, we can see basketballs to football. So the number for basketballs comes first. In this case, we would have 4. And the number of footballs would be 6. So we would write for every 4 basketballs, there are 6 footballs. So our ratio would be 4 to 6. Here I put it in words, 4 to 6. And I can also write it as with a semicolon, 4 semicolon 6, or I can write it as 4 over 6, the fraction. Let's go ahead and look at another example. What is the ratio of sandwiches to Coke bottles? So we go ahead and write our ratio. It's 6 to 8 with a semicolon notation. And let's say we write it as in words, 6 to 8 with the word TO in the middle. And then the last way would be as a fraction, 6 over 8. Now, one quick thing we have to look back at these two examples is the following. Since a fraction can be simplified, so can a ratio, because fractions, you can write them as ratios because they are ratios. And in this case, 6 and 8 can actually be reduced. So we divide the numerator and denominator by the biggest common factor. In this case, we can simplify these by dividing by 2. So I'm going to end up with the ratio 3 to 4, 3 dot dot 4, or 3 over 4. This comes from dividing by 2. We can actually do the same thing with the previous problem, which we had 4 to 6. So we can actually take this one and divide it by 2 again. And here we can get a 2 to 3, or 2 over 3, or 2 to 3. Let's make sure you write these down. All right, so now that we know how to write a ratio out, again, order matters. We got to be very careful with that. Now let's go ahead and move on to the word proportion. So what is a proportion? Okay, so why are we worrying about ratios and why are we simplifying fractions and so on? So let's look at this problem right here in blue. We have 5 over 15 equals 1/3. This is a fraction that got simplified to 1/3. So this is actually a proportion if we see this written this way. So let's look at a proportion. A proportion is just when you get two ratios or two fractions or two of the semicolon notation and you put an equal sign in between. So when you have a fraction equal to a fraction, most likely you'll see it that way. So something like this. And we solve proportions by cross multiplication or cross product, as you may hear it called as well. So in this case, you guys have this fraction here. And what we mean by cross multiplication is we multiply diagonally, like in an X fashion. That's why this is called cross. So when I say cross, I mean these two diagonal numbers get multiplied to each other, and so do these. So we end up getting that 5 times 3, which is 15. From one of the cross multiplications, 15 times 1 is also 15. So we multiply the two diagonals, and then we just stick the equal sign in between. This tells us this is a correct statement, which means the fraction was reduced correctly. That's one way of checking if something is reduced correctly. You just cross multiply it. The diagonal of one direction should equal the diagonal of the other one. All right, so let's go ahead and see how cross multiplication works when we're looking for a missing variable. All right, so just real quick, we have our definition. Let's go into examples 1 and 2. So we're going to be looking for the x value that is not written out. So we're going to go ahead and cross multiply. So my goal is to get these multiplied. I usually circle the one that has the x first. That's 4 times x, which is 4x. And then the other one, 3 times 20, is 60. So I'm going to put 4x. I'm going to put the equal sign. And then 3 times 20, that gives us 60. So again, each one gets multiplied in diagonals on the x shape. And then we put an equals in between. And then we just solve this by getting x by itself, which means we just divide both sides by 4. So all we're doing here is dividing by 4, dividing by 4. We're going to do the same thing on the other one. We're going to go ahead and cross multiply. We're going to multiply the 3 with x. I just like getting the one with the x first, 3x. Put my equal sign. Then 5 times 18, which gives us 90. Then we divide both sides by 3, and x is equal to 30. Now, just one side note I want to make, it's not always going to be a whole number or an integer. You can make it decimals and fractions as well. Let's go ahead and move on to the next ones. So I would like for you guys to try out the other ones on your own. Once you finish them, go ahead and check your answers. If you already get this, just finish the rest of the page, just check your final answers. All right, let's go ahead and look at what you got so far. So let's go ahead and multiply. You should have gotten 12, and you should have gotten 5. So let's see how we get 12 and 5. So when we cross multiply these guys, we get 3x equals, multiply these guys, we get 36, and divide both sides by 3. That gives us 12. The next one, cross multiply the 6 and the x, gives us 6x, equal sign, 10 times 3, 30, divide both sides by 6, and that's how we get that 5. All right, and one thing we want to make sure in all of these problems as we're doing them, we want to make sure we're showing work. All right, let's go ahead and move on to the next ones. Now these next ones are a little different because they actually have the variable showing up twice. So we have to be very careful when we multiply these out. These are a little bit different when we multiply these out. So we're going to start the same way. We're going to start with cross multiplying. I'm going to start with the one that has a binomial on it. Or I guess it doesn't matter. 18 times n. And then we're going to have 18n equals 6 times n plus 6. Now when we write this out, I'm going to use parentheses because I want to make sure when I multiply, I don't forget to distribute. If you want to skip this step because you're going to automatically distribute, go ahead, but make sure you distribute. So we have 18n. We do the distributive property, 6 times n and 6 times 6. Then we go ahead and notice that we have n on both sides of the equal sign, so I'm going to subtract the n from the right side and move it to the left side. I'm going to get 12n equals 36. Divide both sides by 12, and that gives me a final answer of 3. Do the same thing with the next one. X plus 1 times 2. It doesn't matter which pair you multiply first. So it's 2 times x plus 1, and then 3 times x. Actually, I have it backwards from the animation. So when I go ahead and multiply here, I have to make sure I distribute that 2. So 2 times x, 2 times 1, which gives me 2x plus 2. X is on both sides of the equal, so I move the x to the other side, and I get x is equal to 2. And here I don't have to divide because I got a 1x. And I'm pretty much done. That's the general idea. So go ahead and start your practice pages and work on your IXL. Good luck.